This is a demonstration of the GRASS problem-solving technique, and we're going to use the first problem of the sample problems as our example. The example says that a 130-gram chalkboard eraser is initially moving at a speed of 3.4 meters per second on a horizontal surface, slows down and stops because of friction. So the situation is this: the eraser, given an initial velocity, slows down, comes to a stop. Now the first step of any problem solving is to identify the given information and write it down as mathematical symbols, numbers and units. So we'll start with given, and we are given the mass of the eraser, 130 grams. We are given the initial speed, so we'll call that V1 of 3.4 meters per second. They said it slows down and stops because of friction, so that gives us the second velocity, or final velocity, of 0 meters per second. And we are given the coefficient of friction, 0.84. There's no units for that. So those are the pieces of given information in the problem, writing down symbols, numbers, and units for each one. The question also requires something, so we should write that down as well, is how long does it take to come to a stop, which is the time delta t. We don't know the number, but we do know that the unit should be seconds. Now, two things you should think about at this point in a problem. Is there any additional information such as constants that you will need to use? And because we are dealing with friction here on a horizontal surface, the cause of the friction is the normal force of the surface preventing it from going downwards. And that's balancing gravity. And so we do need some information about gravity. So we will include G equals 9.8 newtons per kilogram. The other thing that we should check at this point in the problem is whether the units are consistent. In almost every physics problem, we'll be using what's called the MKS system: meters, kilograms, and seconds. Unfortunately, one of the pieces of information was given in grams, so at this point we should convert this into kilograms. So divide by 1,000, move the decimal point 3 places over, and get 0.13 kilograms for the mass. So now we have a consistent set of information to start the problem with. The next step is the A in GRASS, the analysis. And at this stage in the problem, you want to write down all of the formulas that you will be needing to solve the problem. So these are the mathematical relationships between the physical variables. Now, we've mentioned that it will use friction, so we'll need a friction formula. The force of friction is equal to the coefficient of friction times the normal force. And as I mentioned earlier, on a horizontal surface, the normal force will be upwards, preventing the object from entering the surface, and it will be balancing gravity. So for horizontal surfaces only, the normal force is equal to the force of gravity in magnitude, opposite in direction. And we know that Fg is equal to mg. So these three formulas are going to help us work out the force of friction. We can combine the three of them together, substituting Fg in the place of Fn, and Fg is equal to mg. So we'll get the new formula for horizontal surfaces, that the force of friction is equal to mu mg. Now that's forces, and we're interested in speeds and times, and that means acceleration. So we're going to have to use Newton's second law, F equals ma in order to relate those quantities. And this will be the net force. But again, because the object is sliding along the horizontal surface, the normal and gravitational forces cancel each other. The net force will be the frictional force. So we can say that the force of friction is equal to ma. And that also allows us to substitute this formula in place of the force of friction. So that's going to be equal to mu mg. And at this point we can already see a little simplification. The mass appears on both sides of the equation, so we can divide both sides by the m and cancel out the m, leaving us the acceleration is equal to mu times g. So it turns out we don't actually need the mass of the eraser in this problem. Next step is to figure out our relationship of acceleration to the quantities that we are given, the change in speed and the time. So that's the definition of acceleration, delta v over delta t. And delta v is going to be v2 minus v1. Now one little problem here is that the force of friction is opposing the motion, so it's going to cause a deceleration, and so we are expecting both the force and the acceleration to be negative numbers. So this will be a negative value here, and we expect this to be a negative value as well. Finally, we need to solve for the delta t because that's what's required in our problem. So we're going to have to rearrange this equation and say multiply the a times delta t, divide both sides by the a, and we'll get delta t is equal to v2 minus v1 over a. And we can now substitute a equals mu g. So we get our final formula. Delta t is equal to v2 minus v1 over mu g. Now, as I say, the acceleration will be negative, so this is going to be negative, this is going to be negative, but we do expect a positive value for t. So just to be mathematically sure of that, we're going to put absolute value signs around it. We just want the positive value of the answer. So the analysis section of a problem should always end up with the required piece of information equal to a function of the given and constant information. The next step is the solution, and in this step we rewrite the formula using the given pieces of information. Instead of the variables now we're going to write down these numbers. So v2 is 0, v1 is 3.4 meters per second, mu is 0.84, and gravity g is 9.8. And you may be more familiar with that as meters per second squared, which is also newtons divided by kilograms. Now we get out our calculator and actually do the calculation, and that gives us 0.4130222351 on our calculator. For the units, we have meters per second divided by meters per second squared. Invert and multiply by this. The meters will cancel, one of the seconds will cancel, and we'll be left over with seconds as our units. Finally, the last step in the problem is to answer the original question with a statement. It will take, and now we need the time here, but the original question gave us information with only 2 significant digits for the givens So we're going to have to round off our final answer to the same two significant digits. 1, 2, look to the next, it's less than 5, so we'll round that off to 0.41 seconds. It will take 0.41 seconds for the eraser to come to a stop.